Lesson 3, inscribed angles. You're going to find the measures of inscribed angles. Well, what is an inscribed angle? It's an angle whose vertex is on a circle. So let's look at the picture. Picture is worth 1,000 words. Its vertex is on the circle and its sides contain chords of the circle. Or you could think of its sides as being chords of the circle. Okay, so there, this angle right here, that's an inscribed angle. Inscribed angle. Okay, an arc with endpoints, so now we're talking about an arc with endpoints on the sides of an inscribed angle. So I'm going to do that in green. Endpoints of the arc on the sides of an inscribed angle and its other points on the inside. So here's the arc we're talking about. Right, its endpoints are on the sides of the inscribed angle and all the other points of this arc are on the interior of the angle. So all these interior points here. Anyway, that is the arc that is intercepted, and I think I've already used this term in a previous lesson. That arc is intercepted by that angle. I did when I talked about central angles. I said the arc was intercepted by the central angle. Well, these arcs are intercepted by inscribed angles. How are they different? Well, if you remember, the central angle has its vertex at the center of the circle. So this is a central angle. This is an inscribed angle, and they're not the same. What do you remember about the central angle and the arc it intercepts measure? You remember they're the same, right? If this was 80 degrees, then the measure of the arc would be 80 degrees as well. So guess what's going to happen here? If we have an inscribed angle, and this is our first theorem in this little section, then the measure of the inscribed angle is going to be half the measure of the arc it intercepts. So right here, if B is my inscribed angle, ABC, then I know that the measure of angle B is half the measure of that arc AC. So let's just hop right in here and take ourselves an example. What are the values of A and B? Okay, let's see. I'm telling you, these circles get a lot of things going on. So here we go. Let's look at this. Let's look at this inscribed angle right here. Inscribed angle. Is that the first one I want to look at or not? No, because I don't know what, I'm sorry, I was thinking that the measure of angle P there was 60. It's the measure of angle. It's this measure here. If I look at PQT, so I'm looking at angle PQT here. You might really want to use your colored pencils when you're doing this circles unit. So that is the measure, that's the angle that measures 60 degrees. Okay, so I can figure out from the theorem I just learned that A is going to be twice that, right? The inscribed angles measure is half that of the arc. So if the measure of angle PQT is 60 degrees, then A is going to be 120. And it's already got degrees, so I don't have to put degrees on it. Okay, A is 120. I like to draw this in. A is 120. This is 30 right here. So now I can go figure out what the measure of angle B is, right? Because if I look at this inscribed angle, PRS intercepts that arc that I have drawn in green there, right? So if that arc measures 150, then I know that B is half of 150, which is the measure of the arc. So B has to be 75. Okay, that's how we're using this theorem to solve problems. All right, what about this one that we have here? What are the measures of all these angles? And by the way, we have this quadrilateral, right? The quadrilateral is inscribed in the circle. The quadrilateral is. So let's see what we can do here. Why don't we just start with angle A? Angle A. We know all the measures of all these arcs. Okay, so the measure of the arc that angle A intercepts is 100 plus 90, right? 190. So I know that the measure of angle A is going to be half of 190, which is 95 degrees. Okay, how about B? The measure of angle B is going to be, let me do it in a different color. So B intercepts the arc that measures 64 plus 90. So B is going to be 1/2 of 64 plus 90. What is that? 154. So that is 77 degrees. All right, let's do C. Here's our angle C of this quadrilateral. It intercepts an arc that measures 106 plus 64. So that's 170, right? So the measure of angle C is going to be half of 170, which is 85 degrees. And then I can find the measure of angle D just by adding those three up and subtracting from 160, but it's actually easier to look at the arc angle D intercepts. If I look at angle D here, drawing this in black, angle D intercepts this arc right here, which measures 206. So the measure of angle D is going to be half that, half of 206, which is 103 degrees. So there we go. Okay, so here's the same picture. This is the same picture, and let me write down the measures just so we don't forget. Let's see, measure of angle A was 95. Measure of angle B was 77. Measure of angle C is 85 degrees. And the measure of angle D is 103 degrees. And then the question is, what do you notice about the measures of the opposite angles? So A compared to C, A compared to C, and B compared to D. Hopefully you notice that they're supplementary. They're supplementary, and this will always be the case, I promise. If you have a quadrilateral inscribed in a circle, the opposite angles will always be supplementary. Don't forget that. Okay, so some corollaries to this new theorem. And that is one of the corollaries right there. Corollary 3. Opposite angles of a quadrilateral inscribed in a circle are supplementary. The other two corollaries say, number 1, if you got two inscribed angles and they intercept the same arc, like if you look at angle A here, it intercepts this arc right here, and so does angle B. If these two angles intercept the same arc, then they got to be congruent. That makes perfect sense. I love geometry, it makes sense. And corollary 2 says an angle inscribed in a semicircle is always going to be a right angle. So here's a semicircle. So the two chords that make up the sides of this angle, the endpoints have to be on a diameter, right? Because it's got to be inscribed in a semicircle. And that angle inscribed in a semicircle always will be a right angle. Okay, so I bet that opens up the opportunity for some great problems to work. So let's work a few of them. Okay, I'm going to see how many I got and then how many. Oh yeah, I got quite a few for you to work. So here we go. What is the measure of each numbered angle? Well, the only numbered angle I got here is 1, and I can see that that angle is inscribed in a semicircle. So the measure of angle 1 is 90 degrees because it's a right angle. I don't even care about that 40 and 70, although I could ask you this. Let me ask you this. What's the measure of this angle right here? This inscribed angle. It's going to be half of 110, right? If I call this angle B, I know the measure of angle B is 1/2 of 110, which is 55 degrees, just for fun. Just for fun. Okay, how about problem B here? measure of angle 2, which is right here. Here's angle 2. We want to find the measure of it. Well, look, that angle intercepts this arc right here, right? This 38-degree angle, which is right here, 38, it intercepts that same arc, doesn't it? So the measure of angle 2 equals the measure of angle 1, which is 38 degrees. So what would you know about the blue arc there? What would the measure of the arc be? It'd be 76, right? We got to keep telling ourselves these things so it becomes second nature. Okay, what do we got here? Well, 3. 3's easy enough. I know and 1, right? Measure of angle 1 equals the measure of angle 3. Both of those are inscribed in a semicircle. So I know those are right angles, so they're 90 degrees. That's easy enough. Okay, and let's see here. Let's see what I got. Okay, if this whole thing here, that's a semicircle, so it's 180. If this part of it here is 60, then this part's got to be 120 degrees, right? 120 degrees. I'm not sure if I need to know that, but sometimes I just like to figure out everything I know. And this part here, it'd have to be 180 minus 80, right? So that's going to be 100. So let's see. What am I trying? I'm trying to find. I'm going to get my black again. I need more colors. Angle 2. Angle 2. Oh, I do need to know that. Here's angle 2. Here's the arc it intercepts. Angle 2 intercepts that arc that measures 220. So the measure of angle 2 is 1/2 of 220, which is 110 degrees. And now I don't have to do anything to get angle 4's measure, except look back to the corollary that tells me the opposite angles in an inscribed quadrilateral are supplementary. So the measure of angle 4 is going to be 70 degrees. Isn't this fun? Circles, circles. So much fun. More theorems. The measurement angle formed by a tangent and a chord. Okay, here we go. Here's a tangent. Here's a chord. So this angle right here, that angle is going to be half the measure of that intercepted arc. So let me go over that in red. The arc there. The angle, half the intercepted arc, the angle measure. Okay. So let's just put that right to work for us. SR is tangent to the circle at Q. If the measure of arc PMQ, I'm going to highlight that, PMQ, that's this one right here. It's a major arc, right? Because I gotta label it with 3 letters. It's 212. 212 degrees. What is the measure of PQR? Okay, so here's what I'm looking for, this angle right here. What is the measure of that angle? So how do we proceed? Well, I can figure out the measure of PQS, right? The measure of angle PQS. Let me do that. The measure of angle PQS, because of the theorem just above, I know that's going to be half of the arc it intercepts, which is 212, right? So 106 degrees. 106 degrees for this angle right here. Oh, well, that makes this really easy, right? So I know the measure of angle PQR is going to be 180 minus 106, which is going to be 74 degrees. How come I know that? Because those two angles are a linear pair. And the linear pair postulate tells me that those two angles are supplementary. So all kinds of things from the past coming back that we have to draw on. Okay, we got one more that I'm going to do for you, and then you got quite a few good practice problems that I'll leave you with. What do we got here? KJ, here's KJ. That's my dog's name, by the way. KJ is tangent to the circle at J. What are the values of X and Y? Oh, sometimes you got to take a step back from these and think about it. Ah, look at this. Look at this inscribed angle here with its vertex at J. The one I just drew in blue, that angle is inscribed in a semicircle, right? So I know the measure of angle LJQ is 90 degrees because it's a right angle. I learned that just today. Okay, so that is going to tell me what Y is, right? Because now I got a right triangle. Let me mark it. I got a right triangle, so I know 90 plus 35 is 125. And so Y is going to be 180 minus 125, which is going to be 55. So that angle down there is 55. Okay, and now what do we got to do? Oh, look at this. So Y, that angle there at L, that's an inscribed angle. So if it's 55 degrees, then this arc right here that it intercepts is twice that, right? So this is 110 degrees. 110 degrees. Okay, so I know the rest of this little arc. I'm going to draw it in black. Watch this, guys. This little piece has to be 180 minus 110, right? So that's, I'll call that JL. So the measure of arc JL is 180 minus, I'll put it up here in green so you remember where it comes from. So 180 minus 110 is 70 degrees. Okay, and so if that arc there is 70 degrees, then that x, that measure of that little angle is going to be half that, right? So x is going to be 1/2 of 70, which is going to be 35. So that little angle down there is 35 degrees. Okay, I got quite a few, 1, 2, 3, 4, 5 problems for you to work on, and you might find these somewhat challenging. I'm going to tell you that you need to try to do these by yourself. Pause this video, work them, and then come back and check. Don't just come back and copy them down. That will not do you any good. Okay, be back in a minute. Okay, check this out. I just used all the theorems about inscribed angles and intercepted arcs, and then I had to use the triangle angle sum theorem to figure out what the measure of that angle at C is, and I also had to use the fact that I know the angle that I labeled X is a vertical angle to that angle there at C. So lots of great stuff there. Check yourself, check me, because I'm working these right here on the fly with you, but I got A is 54, B is 30, and C is 96. Check it out. What about this one? Oh, this one's pretty easy. I can see that, okay, that arc there, A, it's intercepted by an angle that's 25 degrees, so the arc has to measure 50 degrees. And I can see that, oh, that angle B there, it's inscribed in a semicircle, so it's going to be a right angle, 90 degrees. And then I can see that C is also inscribed in a semicircle, or I could use the theorem that says since those angles there, B and C, intercept the same arc, that they would be congruent. So in any case, they're both right angles, 90 degrees. Number 3. Lots of interesting things there. I will just let you check your answers. Please put a star on this. If you need me to help you with this tomorrow in class, I'll be happy to do that. Look and see what I got for my answers. Same thing here on number 4. I did not use a calculator, so by all means, check out my arithmetic. Let me know how I did. And then look, I was working number 5, and I was about ready to use the Pythagorean theorem. Well, first what I did is I drew my little right triangle here in black, and I labeled this side right here, I labeled it Y, because I knew that since this side that's 5 is perpendicular to that chord, that X is going to be 2 times Y. So I was just working with my right triangle there, and I suddenly realized 5 and 10. Hey, wait a minute. That's a 30, 60, 90 triangle, so I didn't have to use the Pythagorean theorem at all. I know that that long side there is going to be the square root of 3 times the short side. And then when I multiply that by 2, I find out that that chord length x is 10 times the square root of 3. So lots of good problems here inside of these circles. Please keep practicing. You have many, many worksheets that I'm not going to assign all of these to you every day in class, but you really need to keep working so you don't forget how to apply these theorems. Our next class, we only have 2 lessons left. Our next lesson will be on segment lengths and angle measures, and then finally we'll do circles in the coordinate plane. So keep working, and I'll see you next time.